state of our waterways, how to improve water quality, and ways to enjoy the rivers around us. We're recording this session, so be aware of that. I'm Mike Whirling, a technical specialist agronomist for the SWCD here. I'm a conservation advocate in restorative agriculture. I farm in Adams County and love the new practices. Please keep your audio on mute unless asking a question. We'll be monitoring the chat if you want to put something on there. Both of our guys say that you're welcome to raise your hand and ask a question anytime, because we're ready to, it's going to be an informal session today, and we're going to hopefully have a good time. We have Dan Wire from the Maumee Watershed Alliance, and he has a lot of hats, I know. Self-described river rat, been on the river for all the years. And Bob Gillespie from Purdue University Fort Wayne, retired, I believe, just recently, and a lot of knowledge on water quality and the sampling and the state of our rivers. So I think what I'm going to do is let Dan start. It will just take off, and let's see what we can do. Good morning, Dan.
Yeah, okay, let's get the mute button off. Bob and I, as we talked about this, we certainly want to make sure that everybody feels comfortable to just jump in when they have a question. Probably the most important thing we could do for anybody this morning is to answer their question or entertain a comment, make sure that the information we're sharing is relevant. You do usually take a little time to explain, as Mike said. I guess if I have an official title of anything, it's just a river rat. I spend a lot of time on the water, so I'm not a biologist. I'm not necessarily an environmentalist, although I'm aware of the environment along the riparian corridors of our rivers. And I love to throw this one out. I'm not a fluvial geomorphologist. But with all of that, I do work with all of those entities. And so I just bring the local knowledge piece of our particular rivers. And then I really got stretched out when I joined with Mike's organization, the Soil and Water Conservation District. I spent some time as a supervisor on that in Allen County. And boy, did I learn about the 1.2 million acres that comes right through downtown Fort Wayne. And so water quality is a big question. There's a lot of things that everybody can do about it, but there are a lot of misconceptions out there. Somebody like me may be inclined to want to say, oh, these rivers are great, come out and recreate. But I want to share a couple things with you here if I can, because the title of what we want to share here is water quality. What do we think, what do we know, and what can we do? So here's just an image of the confluence of the three rivers. And of course, we know that we can look at the rivers and they look brown. We're inclined to think, oh, geez, that's just horrible. So we try to get people to come down to the rivers, and we have to understand that, first of all, this is a perception. This is what people think about the rivers. As we get further into this, I'll explain this slide a little bit more in detail, but we see this. Let's see if I can advance this. Mike or Bob, help me out. Are you seeing the confluence of the three rivers here?
Yeah, we're seeing the photo of I can see the St. Mary's River on the left. It has a little more clay in it, a little more turbidity, and the St. Joe on the, well, probably behind you and or to the right. So
okay, I think I might have just brought up the image as compared to the slide I wanted to share. Let's see if this one works.
Yep, we can see the slideshow. There you go.
All right. And we know we see this as well. And we'll come back to this slide, but this happens to be in front of the old fort. This bank was eroding at the pace of about a foot a year. And I know this is very simple math, but just to make the point, the reenactors of the old fort, the events that they hold on the property, over 10 years, they lost 10 feet of their riverfront. And you can see some trees threatened there. This area has been addressed, but we need to understand why. And then why do our rivers look like this at times? And again, we want to talk about water quality and help people to do the best they can to improve the water quality. But we see images like this, and we absolutely have to wonder, is it really worth the effort? Is there anything that we can do is the science on it. So these are some images that we know. Maybe this is what people think. This is what they know. This is what they see. But it's what they don't see and what we can do that we want to focus on today. And this is the very same river, and I'm going to stop sharing here in a moment and pass it off to Bob. But I do want to share that this has not been photoshopped. You can look at the water and it looks blue. And I like to use this phrase when they say, when you look at water quality, it has to do with your perspective. How are you looking at it? Of course, the perspective here is just reflecting the blue sky, but that's what we want to do. We want to help improve your perspective and the way you look at the rivers, our riparian environment, water quality, and come away with a bigger understanding and hopefully answers to your questions. So with that, Bob, I'll pass it off to you.
Can you come off a mute too then? Make your audio live, Bob?
Sure. Let me get somebody out of the way here. I can manipulate this. There we go. Just had to move some heads. Okay, I think we're set to go. So good morning, everybody. Happy fingers there. Try this again. Yes, good morning, everybody. My name is Bob Gillespie, and as Mike said, I am a retired professor of biology at Purdue University Fort Wayne. And the reason I'm here collaborating with Dan about the rivers is primarily because of the association that I've had with two watershed groups in Northeast Indiana. I've been a board member of the St. Joe River Watershed Initiative since, I don't know, maybe the late 90s, and one of the founding board of directors of the Maumee Watershed Alliance. And over those years, I made as best of an effort as I could to help with interpreting data for water quality. My research at PFW also involved water quality issues, but it was more biological impacts of agricultural activities on aquatic organisms. And I was in a conservation effects assessment project for almost 13 years before I retired. So I am really happy to present to you some of the results of data that I've analyzed over the years to, as Dan said, to help answer the questions of what do we think, what do we know, and what can we do. So I'm going to start off by providing you with some information about the state of our rivers. So as Dan showed just in a few slides before, that I think most of us who've been exposed to the rivers in the Fort Wayne area and in their upstream watersheds, that we think of the rivers as muddy, dirty, smelly. And I have to admit that perhaps when I first moved here and got started in aquatic biology of the region, I felt the same way. But over the years, having been on the rivers quite a bit, having projects that included both water quality and biology on the rivers, I have a very different perspective on it. And I hope that comes through. So again, what do we think? Muddy, smelly, stinky, algae-ridden rivers. And what I'm going to do is start off by claiming that there are three major water quality problems in our three rivers, but this isn't just isolated to Northeast Indiana. What I'm going to talk about are water quality problems that are typical throughout the Midwest for rivers and streams of types like our Maumee River watershed. So perhaps the most important pollutant of these Midwest streams and rivers are what we refer to as total suspended solids. And that's a general term for a lot of the particulates that simply float and cause those muddy looking waters like you see here in this slide. And the sources of those are typically erosional particulates coming off the landscape, in agricultural landscapes, impervious surfaces in urban environments. And the problems that they cause are primarily one of drinking water and aquatic life. So the major impacts of suspended solids are with that we have to take them out to make good clean drinking water. And so that's why our water drinking plant is called the filtration plant. A lot of what it does is get these total suspended solids out of the water, and it's incredibly effective. But it's expensive. It's expensive to do. But I would argue that suspended solids per se aren't a real problem for human health. Now I say that in quotes, and I'm not showing you quotes, but just in case there's any health experts out there who might disagree. But suspended solids are a real problem for aquatic life. They basically can destroy spawning bed habitats, cause a loss of aquatic vegetation, and they can clog gills of fishes. So suspended solids, number one. Secondly, I would put fecal matter as the next major water contamination issue. And fecal matter produces or releases potentially pathogenic microbial organisms that can be a threat to human health. And the sources include failed septic systems, combined sewer overflows like you see there on the left, livestock, wildlife, and that is primarily a human health concern. To my knowledge, the potentially pathogenic microorganisms that might come from those don't affect aquatic life. And then the third group of contaminants that I think are a major problem are nutrients. And the nutrients comprise nitrogen, phosphorus, and different species of those chemicals. And the primary sources are, of course, of fertilizers from agricultural lands, from urban lands, from suburban lands, wastewater, like the combined sewer overflow that you see there, and of course, livestock operations. Nutrients are a potential ecological problem. The nutrients, if they exceed a certain threshold, can create excessive algae blooms. We'll get into that a little bit later. And if that occurs, and if there is, heavy organic material in our rivers and streams, then the microbial breakdown of that organic material, including the algae, sucks oxygen right out of the water. So those are the three, what I think the experts say are the major three problems of pollution in our rivers. So we think about our rivers around here again, and I don't know, Dan and I sort of agree that the first impression, I guess, is one of stinky, smelly, and muddy water. And so, but, and you can see that, and depends on hydrology, what it looks like and how bad it is. But the question I want to address now is, how bad is it? So suspended solids are there, fecal contamination, the potentially pathogenic bacteria are there, and there's phosphorus and nutrients that exceed certain levels of water quality. So what I want to do is tell you about the Three Rivers Monitoring Program that has existed since about 1996. And it started with the creation of the St. Joseph River Watershed Initiative. It now comprises organizational collaboration among the Maumee Watershed Alliance, City of Fort Wayne, Allen County, City of Defiance, and other partners I'll list a little bit later. The purpose of the origins of the monitoring program were about pesticides in drinking water. And I don't want to take time to go into that, but it had to do with atrazine being in drinking water of several cities about the same size of Fort Wayne and larger that had atrazine at risky levels in drinking water. But in any case, the purpose of all monitoring programs are to identify problem areas, sources, and then assess the quality of the rivers and the waters against human health and aquatic life benchmarks. It also provides information to resource managers and other stakeholders who are decision makers. So again, our monitoring program is a cooperative effort by two very successful nonprofit watershed organizations. The City of Fort Wayne does a lot of in-kind work for our program. The Allen County SWCD has a major role in doing the sampling and entering data. And we have also partnered with the City of Defiance that does its own monitoring, but we're collaborating on data and data analysis. The National Soil Erosion Research Laboratory of the Agricultural Research Service, USDA, in West Lafayette has been a supporter of the program by running analyses for us at no cost. And then the Department of Biology and the Environmental Resources Center have helped in many ways, but most importantly, most recently, creating a water quality database that I will bring up a little bit later. All right, so this water quality monitoring program has been fairly consistent over these past 25 years. We monitor 28 sites over 30 weeks of the warm season, of the year. We measure and record physical chemical data, that's dissolved oxygen, pH, conductivity, temperature. We also monitor analytes, and those are things like atrazine and E. coli, total suspended solids. Turbidity is a measure that can be a surrogate for total suspended solids. So if I show data with turbidity, you can just substitute that for total suspended solids. Just don't tell anybody I told you that. And then E. coli, atrazine, total phosphorus, dissolved reactive phosphorus, and nitrate. We monitor all of those once a week over 30 weeks, 28 sites. Currently, and I think this is up to date, and Mike, you can correct me if I'm wrong, but we're currently monitoring 9 sites in the St. Joseph watershed. That's up here in the kind of burnt orange. 9 in the St. Mary's, yellow. 9 in the upper Maumee, which is gray. And then I think we have 1 site in the Auglaize, which is here in the paint. It's a big program. So here's what happens. We chose initially when the monitoring program was created to primarily sample in the tributaries, the major tributaries of the 3 rivers. And the reason for that is it is very helpful at identifying sources and answering questions so that we can improve water quality if it needs. So here's one of the texts from a long time ago with our homemade water sampler, which has been very effective, and sampling from the bridge. And that's how we do that most of the time. This is one of our physical chemical monitoring machines there. Okay, so we're going to transition from what we think about the rivers, which we haven't hammered that home yet, is that they stink and they look bad and they're muddy and dirty, to what we know. And what I mean by that is I'm going to show you some data, and I promise not to make this too drawn out, that I think shows patterns or answers questions that I think are important, and hopefully you do as well. The data I'm going to use comes from 2 sources. One of the sources was a stormwater project by the city of Fort Wayne, 2014-2015, where they assessed the impact of stormwater runoff on several water quality parameters. And so what they did was sample the base flow when things were dry, and also sampled shortly after storms in all 3, the St. Joe, St. Mary's, and the upper Maumee River. So again, here's the St. Joe, St. Mary's, upper Maumee. Now, before I get going, I want to point out that on the slides, I'm going to show you the data graphs that I inserted water quality benchmarks. Those are thresholds above which bad things might happen. And so the benchmarks come from a few different sources, and I don't want to take too much time for that, but you'll just have to trust me that we're using the best benchmarks for these pollutants. So what I want to do is first show you that what we know is that contaminant levels in our rivers is event driven. Now that may seem fairly simple and obvious, but in fact, you might not even know that. I mean, a lot of people might not even know that is the case. And what we know, and I can't cite figures, Mike might be able to, and Dan, but what in a typical warm season where most of the contamination occurs, most of the load of these contaminants occurs from rain events. So here is a graph of total suspended solids 2015 during the stormwater project. And what you can see is that you compare the wet concentrations with the dry, it's very obvious that the effect of the stormwater input in this case has caused very high concentrations of total suspended solids. I need to move this.
Hey, Bob, just to add here, as people are looking at this first SR may confuse them a little bit. That is Spy Run Creek. Is that correct?
Yeah, hold on, Dan. Let me get, there we go. Okay. I had to get something out of my way. I couldn't see that. All right. So, let me back up here. Man, okay, now we're in. Okay, so thanks, Dan, for reminding me about that. So to orient you, the sites represented in the stormwater data include Spy Run Creek, which is a tributary to the St. Mary's just before it forms a confluence with the St. Joe. So we have a Spy Run Creek, and I'm going to ignore Spy Run Creek, focus just on the St. Joe, St. Mary's, and the upper Maumee River. And so again, the point of this comparison is simply to show that contamination is primarily event driven, particularly for, at least for this year, for total suspended solids in the Maumee River. What you're going to see here by the end of the data that I present is a very, very consistent pattern. And that is that for most of these contaminants, the St. Mary's is always higher, the St. Joe is lower, and the Maumee is typically somewhere in between. And pedestrian way of explaining that is simply that the St. Joe River dilutes the St. Mary's as it comes through Fort Wayne, and the Maumee River then is the sum of those of that confluence. So in this case, the water quality benchmark is 40 milligrams per liter, and you can see that just about every wet event exceeded that benchmark. During the low flow, base flow, it did not. Contaminants, event driven. For concentration of E. coli, which is an indicator microorganism for fecal contamination, the data are extremely obvious that particularly in the area where these samples were taken, the effect of precipitation, water runoff, urban runoff, combined sewer overflows created a significant increase in E. coli concentrations. There are a couple of different benchmarks, but none of them are really at all above this line. And in fact, this problem is consistent all over the Midwest. Now for nutrients, I'm going to show you data for total phosphorus and dissolved reactive phosphorus. Total phosphorus shows a very similar pattern that we've seen with the other contaminants. During base flow, the orange, in these three rivers, we exceed this benchmark. We'll come back to that. But the regulatory benchmarks are exceeded in our case during the stormwater project only when there is high levels of precipitation. But notice that even during the dry periods in the St. Mary's and Maumee River, that the concentrations of total phosphorus are not too far away from that water quality benchmark. This standard right here that all of these data exceed is a very, very strict reference benchmark that comes from statistical analyses of similar streams in the Midwest. And so it represents the concentration of the best 5% of the streams in that ecoregion, and simply means that the top 5% of the best streams in the ecoregion have concentrations of total phosphorus that are below that mark. So that's a very strict benchmark, and it isn't surprising that we exceed that even in dry periods. But the wet periods again show that contaminants are event driven. And then finally, yes, sir.
Bob, I have a question on that last slide when you talk about that 5% in the ecoregion. And I know because of our glaciation activity here, we've got a lot of different soil types. Can we either give ourselves a pass on the St. Joe, St. Mary's, and Maumee rivers because of soil type when we compare against those best five? Or are those best five in very comparable soils like we do on these charts? And really, maybe it's more a problem of land use than it is of soil composition.
Well, my understanding is, Dan, that the ecoregion accounts for soil types. So,
okay.
And ecoregions have scale. And I think this is the ecoregion that encompasses either all or most of those three rivers. But that's a good point. Those references will vary by ecoregion, and soil type is one of the criteria for that. It's a good point.
Thank you.
Okay, so the last contaminant in this series here is dissolved reactive phosphorus. Again, this is 2015, the stormwater project. And certainly before these data were collected, it became known that dissolved reactive phosphorus was very important in stimulating algal blooms, particularly in the western basin of Lake Erie. So we are really concerned about dissolved reactive phosphorus. And you can see that it mirrors pretty well with total phosphorus, but there are different benchmarks because of the concern about how dissolved reactive phosphorus stimulates algal growth. But again, definitely greater concentrations of the dissolved reactive phosphorus during wet periods than dry. But you'll notice that in St. Mary's and Maumee River, that again, the rivers, even at base flow, the dry period, exceed the water quality benchmark. Okay, so I want to take a a different look, but you've already seen this in the previous data, that contamination differs among rivers. So what I have here are data that are from our watershed monitoring 5-year period from 2014 to 2018. And we're just comparing medians. So you can think of these lines here as averages, if you wish. That works. Just to show what I've already pointed out, and that is that for, in this case, turbidity, which we're using as a surrogate for total suspended solids, the St. Joe has lower concentration, certainly than the St. Mary's. And here again, because the St. Joe dilutes the St. Mary's, the upper Maumee is somewhere in between. That is true for, oh, and this is really interesting, that we are exceeding the water quality benchmark almost all the time. And so these, you're going to see this pattern over and over again through these different contaminants. So for E. coli, it's a similar pattern. St. Joe is the lowest, St. Mary's is higher, and the upper Maumee is somewhere in between. In fact, this case, it's interestingly similar to the St. Joe River. Total phosphorus is a little different. The St. Joe River, again, over 5 years worth of data shows that it is significantly less than both the St. Mary's and the upper Maumee River. And to a lot of people in the room listening, that is not a surprise. So getting back to the concern about dissolved reactive phosphorus, we see a very similar pattern to the total phosphorus. So contaminants, contaminant concentrations differ among the rivers. And for many of the contaminants, we are exceeding water quality benchmark. And so the last set of data I put in because a lot of stakeholders want to know, well, are things getting better? Are they getting worse? What's going on? And that's a tough question to answer, primarily because the experts tell me that in order to answer a question like that, you have to have years and years and years of data. The data that I have here was limited to 5 years, but I think that the point is still credible that there is quite a bit of variation from year to year for concentrations of these contaminants. This is the St. Joe, and like before, you can see that they rarely exceed the water quality benchmark, but there is variability from year to year, and it is almost certain that these differences over those years is due to hydrology, which means precipitation. Total phosphorus, very similar same thing for the St. Mary's. It exceeds the water quality benchmark more often than the St. Joe, but it has the same, almost the same type of variation, which is easily explained by environmental process. And of course, then the Maumee looks exactly like, well, almost exactly like the pattern of the previous two. So the point here is that contaminant concentrations differ among years. So what I'm going to do here before we move on is to stop and let everybody, well, I'm going to let myself have a sip of coffee just to see if you have questions. And I think if you do, please just open your mic and ask, and I'll try and answer it. And if I can't, I'll find somebody who can.
Okay, what questions do you guys have? See if we can stump Bob.
Jump the professor.
Stump the professor.
Bob, I have a question that you might be able to answer. You mentioned here at the end that these elevated levels of contaminants, whether it's phosphorus or sediment, suspended solids, are hydrology driven. And I always try to just break that down to the simple. I'm assuming that's rain events. What sort of studies are out there that can lead at least to maybe the hydrology event of causing these elevated levels? Meaning, are we getting more water significantly during those events, or is the way we're handling these rain events different that's causing these elevated levels of contaminants? So what do we know about the hydrology cycle? Maybe is the question.
Well, what we do know is, of course, that high precipitation events will increase discharge, and I don't want to get too far in the weeds here, but I think the answer to your question, Dan, is when agencies, organizations that calculate loads rather than just concentrations, we can see that the hydrology has a major effect on how much of the contaminant is actually in those rivers. And so, yes, researchers have done that, and they've shown that the hydrology very much contributes to the concentrations, but of course, more importantly, contributes to the total amount of a contaminant that gets in these systems. But what we also know is that due to climate change, the amount of discharge, amount of precipitation causing greater discharge should be having an impact on these loads. So I don't know if I answered your question, but if not, we can chat, and I'll see if I can do a better job.
Yeah, Jim Mosley here. Can you hear me?
Yeah,
Yes, Jim.
go ahead,
Very
Jim.
good.
Yes. I'm curious, Bob. This is 24 to 18, or I'm sorry, 14 to 18, 5 years. Was this a particular study? I joined a little late. Was this a particular study, or is there ongoing data that's going to come onto this chart? And what I'm particularly interested in is 219 and really the dramatic shift in hydrology that we had in that given year.
Okay, that's a good question. The reason that I chose this 5-year period was either because somebody asked a question, or it's because the sites that we use, some of those sites probably weren't started in the program, particularly in the upper Maumee, until 2014. We do have data for 2019 and 2020. We haven't put those into analysis yet, but as you suspect, with that greater precipitation and greater discharge into the stream, we might see a spike that would explain that. And it looks here to me like possibly 2015 and 2017 were wet years. And I'm pretty sure 2016 was a dry year, if I'm not mistaken. You guys can probably answer that. We have the data, Jim, but I haven't graphed it yet, but I'll update these soon.
Hey, Bob, I'd like to ask a question or a comment. I've heard it stated that the St. Joe River and the St. Mary's River are very different types of river, the way they operate. The St. Mary's being a straight, deep channeled, solid channel one, and the St. Joe being more of a meandering river. Any comments to that?
Well, it does. It definitely has an impact, and one of those, and the impact is mostly seen in total suspended solids and turbidity. And I think that probably explains why the St. Joe has a significantly lower turbidity, significantly lower total suspended solids. It also has to do with their riparian area as well. The riparian area of the St. Joe is much more developed than it is for St. Mary's. And Dan might be able to talk more about that. But yes, so the geology of those two rivers is very different. And it does have it really does contribute. As I recall, Mike, you can correct me if I'm wrong. I think the St. Mary's system is more susceptible to runoff. Is that right? Than the St. Joe.
Right, yeah, I think so. The St. Mary's, the fingers of it, the headwaters of it are flat and easily accessed. And then and Bob Barr has said that once the turbidity, the clay particles, the suspended particles get in the river, they stay in it all the way through the system. There's no place for them to settle out. So
exactly, yeah. And so the landscape and geology of the St. Joe and the St. Mary's is very different, and that certainly contributes to these differences. Thanks, Mike. That's a good point. All right, I'm going to move on, and if you still have questions, I suspect there will be time later on, and we'll try and answer those questions. Okay, so all right, so we've discussed briefly what we think about the rivers. I just provided you with some data that supports what we know about the rivers and its water quality. And I want to summarize an answer to the question how bad it is. And to do that, of course, you simply have to compare these concentrations in these rivers with those benchmarks. So the way I do this best is to take those data and compare them to the benchmarks and calculate the percent of the samples that exceeded those quality benchmarks. So of course, high percent means that the total suspended solids are high or beyond the benchmarks. Dissolved reactive phosphorus. It's a percent of samples that will exceed those benchmarks. And you clearly can see in summary what's going on here. And we've sort of built up to this by looking at those graphs. For total suspended solids, you can see clearly that St. Joe, and we were just talking about this, is quite a bit lower on average than the St. Mary's and the upper Maumee. Fecal contamination, the same thing. St. Joe, lower than St. Mary's and upper Maumee. The phosphorus, the nutrients, is even more stark if you compare the St. Joe to the St. Mary's and upper Maumee. And then, and so what this tells us is if I had to walk into the environmental court of Northeast Indiana and answer the question, how bad is it? Well, I would be forced to say, well, I wouldn't be forced to say. What I would say is that based on the evidence we have, the St. Joe, St. Mary's, and upper Maumee have water quality problems that comprise TSS, E. coli, and phosphorus and nitrate, nitrogen. I didn't show any nitrogen data, and that is fine. But what concerns me, and if there are any regulators in the room, please close your ears, that these benchmarks sometimes are very conservative. Well, I'll just say that. And so what a follow-up question to how bad is it might be, well, how bad is it for human health? Well, our drinking water is one of the best in the country, according to city utilities. I'm saying that tongue in cheek, but they have one taste test contest. Your drinking water is very safe in spite of this. What about the aquatic life? Are they okay? Well, I'm going to touch on that in a minute. Some of those benchmarks were benchmarked specifically for aquatic organisms. And what I will say is that at least our system is no worse than a lot of the same systems that have similar geology, similar precipitation, climate in the whole Midwest. These are very common problems. So as a biologist, I'd want to know, and we should have been more prepared for this, but I want to know what the impact is on our aquatic life. It's not that I don't care about humans. I am human, and I do worry about that, but I think that we can more easily protect human health than we can aquatic life. And I'm going to just touch on that in a minute. But what I want to do is bring to your attention, because we did, okay, let me get back to this. Back it up. As I mentioned, the dissolved reactive phosphorus and total phosphorus in St. Mary's and Upper Maumee are a bit of a concern because they do exceed these concentration benchmarks. In particular, we're concerned about the western basin of Lake Erie. And many of you know, back 7 years already, the city of Toledo had to close down its drinking water intake, and you can see why. You can see all the green around the intake because of algae blooms that were driven by excess phosphorus in the western basin of Lake Erie right here. And I'll just say that it appears that the St. Mary's originates in Ohio, comes into Indiana and goes back out of Indiana into Ohio and onto the Maumee. But the St. Mary's, because of its higher concentrations of phosphorus, is an area of concern. And so we need to keep monitoring to see if our remediation projects are working. And so in 2017, unfortunately, this photo was taken in Toledo. The EPA is called for stepped up efforts. And in addition to EPA drivers, there was a concerted binational multi-state effort to reduce phosphorus 40% by 2025. And ITEM and the USGS and with help from SWCDs and others, they determined that, in fact, the St. Mary's, you can see in this is the border here, in Indiana, may have been a problem for contributing phosphorus to the Upper Maumee and onto Toledo. And there are some efforts going on in there, and maybe somebody can speak to that later, but that's an ambitious project. And I hope that we can at least work our way towards that. So monitoring is really important. We have problems with total suspended solids, fecal contamination, and nutrients. So again, what I'm Okay, so if you're interested in accessing the data that we have, the data I use in most of this presentation so far has come from our water monitoring project database. It is housed at the Water Quality Information Service that is managed currently by the city of Fort Wayne. And I'm not going to go there because I've tried that in the past and it has completely exploded on me. So if you're interested in this, after we're done, I'll give it a try. I just don't want to mess things up now. So if you're interested in seeing how this works, I'd be glad to do it after we're done talking. I just don't want to mess up the presentation. So is there, let me stop there for a second because I think, yeah, I think what I want to do is to see if Dan wants to take over for a bit. We can always come back to this afterwards. So Dan, do you want to go ahead and talk for a bit?
Yes, but before we do that, Bob, I don't want you to leave yet and your information. I want to stay with the science for just a little bit. If you can back up just a couple of slides to where we look at, okay, percentage-wise, how often are our rivers impaired? I want to just cue up a little bit on that science. I guess, yeah, slide 25, right. So as I present, and again, not from the scientific point of view, but what we're doing along the rivers, engaging people, providing that voter base that's going to support initiatives to be good stewards of our water, I would take the just the fecal contamination line there, second one down with the data. People understand the rivers are brown, they understand there's sediment in it, and often they think that's the bad mojo that's going to hurt them. And for most human concerns in using the river, it is the fecal contamination. What's the chance of them getting ill because of their experience with the water? So just for those participating, I have a tendency to just use real general numbers. So I would look at the St. Joseph River, seeing that it exceeds water quality benchmarks 26 to 37% of the time. I'd use real round numbers and say, okay, 25% of the time it's going to exceed that, maybe a little bit stronger than that. But I would flip it around the other way and say 75% of the time it is within those boundaries. And that's an opportunity that I often take, and I want to share that in case I get something like that down the road here as we talk, that I'll say, hey, you know, a fourth of the time we've got challenges with it with fecal bacteria, but 3/4 of the time, you know, that's fine, go out and recreate. There's certain precautions that I'll share a little bit later that you want to use while you're out recreating on the river, but we can do that. And then the numbers for the St. Mary's and Maumee certainly bear out. If people are asking me, hey, what about the rivers downtown Fort Wayne? What can I play on? What can I do? Is there a better one? Is there a worse one? Then these numbers sort of bear out as your conversation with Mike shared that the topography of the St. Mary's River and the land use makes it a little bit more of a challenge, you know, specifically in staying on that second line of the fecal contamination. And then, of course, that just gets washed right into the upper Maumee. And I like the way you categorize that. Sometimes the St. Joe will have a tendency to dilute the effects of the St. Mary's, which is certainly scientifically accurate. So I wanted to use this slide because some of the comments I'll make about, you know, can we recreate on the rivers and what safety precautions do we need to take? Most of those are focused on the fecal contamination. We use the term E. coli, and Bob just kind of brushed on it quickly. That is just a measurement we use to determine what is the fecal contamination in the river. So, Bob, if I got that straight, I didn't muddy it.
That's a common what we call indicator
Right.
value, but yeah, it's supposed to represent the risk of all potentially pathogenic microorganisms. So, but yeah, it's the standard.
Okay, and then a second thing, and Greg Lake, I know you're listening here, and you've not been asked to come present, but I think if you can, maybe provide a little information for those of us that are here, specifically the domestic action plan and what the targets are for 2025. I don't expect you to get into the details of that, where are we, but maybe it'd be helpful for some of those listening that in light of a lot of this research that has been done on water quality monitoring the rivers and what we know here, collectively the region, and that, Greg, is what I maybe want you to help explain to the folks. What is the domestic action plan? Who's all involved in it? What just some broad strokes are the parameters of that, so we understand, because this is a pretty critical goal and document that a lot of our water quality efforts are measured up against. Greg, would you be comfortable to just give a little general background of the Indiana Domestic Action Plan, and feel free to be specific on the Indiana side if you'd like. Well, that was a lot. Maybe Greg stepped away. Okay. We may come back to that. If anybody else has any questions, because I wander away from the science. Bob, I really like what you presented. Does anybody else have any questions for Bob regarding this science and kind of the factual analysis of, where are our rivers and water quality, and what effects does it have on us as individuals?
Yeah, if time allows, Dan, I'll come back to kind of finish up a few thoughts, because it might flow from what you're about to share. But your comment about the E. coli in that table reminded me that to say, again, in a very simple way, that those numbers sometimes don't help people at all. And it is important for the experts, health experts, ecologists, water quality managers, to make sure that citizens, stakeholders understand what it really means. Would I drink the water, even of the St. Joe? Heck no, not raw. Would I swim in it? Well, maybe in certain parts, keep my mouth closed. And would I kayak? Would I canoe? Absolutely. We do have to be careful, and it would be nice, and maybe I should challenge myself to do this, is to put a tag on those numbers that maybe gives it a better perspective. Just exceeding benchmarks may not be a problem at all. Those are fairly conservative. So I want to make sure that people understand that by exceeding those benchmarks frequently does not necessarily mean that you should stay away. Okay, so thanks for stimulating that. And I'm going to stop share and let you start sharing.
Okay, very good. Thanks, Bob. And Bob, thank you very much for all that data. I hope one of the first big takeaways that the folks are hearing is that there has been ongoing research. There's a lot of research that's out there, and we do know the particulars from a fairly good standpoint of what the condition are of our rivers and our water. So I'm going to come back to this because this is just what I started with. And as Mike identified, on the left is the St. Mary's River. On the right is the St. Joseph River. This is the confluence where the two come together, and it's the headwaters of the Maumee River. So often we'll see one river overpower the other one. And, in my mind, I'm going to say I usually see the St. Mary's this way, but that's not really necessary. Sometimes the St. Joe watershed gets most of the rain, and you'll see this color variation between the two. What most people have in mind is, yes, the rivers are very brown, and in Bob's aerial photo, you saw they were brown. I've got one that may come up later, and a comedian came to town and said, okay, where's Willy Wonka? Because I see the rivers of chocolate. I think we just have to understand that primarily that's our suspended solids. That's the mud puddle. And what is it that we're doing that's causing that much sediment to come in? So this is the confluence, and this intersection of these two rivers right here drains a little over 1.2 million acres. And as people want to learn about the rivers, what can they do on the rivers, are they safe or not, depending on where you are on the river, it may be the end result of a large, square miles drainage area that maybe right here in the heart of Fort Wayne, maybe we didn't have a rain event, but it did happen in Decatur and Salina, Ohio, and our rivers come up, we've got blue skies, but this is what we see. So the point being that because we have 1.2 million acres that are the headwaters of the Maumee River, we've got a lot of land that can affect someone's ability to use the river, even if it wasn't a hydrology event in their particular area. This project right here, as we have taken fluvial geomorphologists out on the river. I love the term, but that's great science. The Maumee River Basin Commission has done 3 complete studies now of the St. Mary's River from Salina, Ohio to the confluence, the image we just saw. They've done the St. Joseph River from Hillsdale County to the confluence, again, the image we just saw. And then a study of the Upper Maumee River, and I'm not quite sure how far in Ohio that goes. That was the first one that was done several years ago. And I believe the Maumee River Basin Commission might want to come back and have another look at the Maumee study, now knowing the parameters and the data that they've come up with from both the St. Joe and the St. Mary's study. Interesting enough, even though we see erosion, pictures like this, we see it along the rivers. Comparatively, when we look at rivers and streams, throughout the country, and even in Indiana, these rivers, neither of them are identified as being highly erosive. We do have a high clay compact makeup of the soil, and that partly is to credit both for the stability of the banks, because it is clay, but that's also part of the problem of the turbidity, because it is a very fine material, and when clay does get washed into as a loading item, it stays suspended for a long time because it's so light and so fine. And one of the challenges we have with water quality as well, that people get a little bit confused, is in the city of Fort Wayne, we have the ability to open a gate on the dam and, for all intents and purposes, drain the river. This happens that you happen to be looking at State Boulevard Bridge. This is on the St. Joseph River, about a 1/4 mile upstream from the confluence. It's a very flat bottom. It's a very sandy bottom. But this at normal river level really is only about 4 feet deep. It's easy to recreate in this area. You're going to see a picture. I've got of this later on. I reference this as Sunset Bay. It's a very pretty image. But what we don't know is what's just below the water. And so, this is an unfortunate situation, I guess, in my eyes, that we can have a tendency to do this. There's a very structural advantage to it. If we're going to do work along the rivers, we can kind of drain it and get down there with a little bit more ease. But this is really impacting the wildlife in and along the rivers, because it gets very confusing as to where is that water level. And as a result of, and I'm going to say this 1.2 million acres that comes through, there was a figure that was shared, and I'm going to say this was maybe 8 years ago, 5 years ago, from a Nature Conservancy individual, and this is a very loose calculation, but between Fort Wayne and Toledo, as you drive by car, 24, and it's almost a straight line, but it's 92 miles from Fort Wayne to Toledo. Yet, this back of the envelope calculation is there's over 600,000 miles of subsurface drainage, meaning drain tiles underneath the land to wick away the water, the storm events, so that we can get in and use that land at a quicker rate. Again, 92 miles to drive to Toledo, 600,000 miles of subsurface drainage, which means it's pushing a lot more water into the stream bed than they were designed for. That creates your erosion on the side, that has a tendency to undermine trees, and then you can see what happens here. We get big events, maybe somebody's got a trash pile in the back of their yard, river comes up, grabs that, and brings that debris along with some of the eroded material. But as we look at the rivers and we want to use them as an economic driver, it's a balance between the science that Bob shared, the initiative that's out there before 2025, 40% reduction in nutrients, and how do we work with the public to help them understand that they can enjoy and recreate along the rivers as long as we've got a fair knowledge of what's acceptable, what's not. And I think Bob did a great job of categorizing, would I take a glass of water out of the river and drink it? No. Would I go swimming in it? Maybe not intentionally. There's some precautions you can take if you get wet, if you fall in, or if you choose to be in the river. But then recreating, as you're seeing in this picture, boating on top of it, being along it, looking at it, all of that stuff is absolutely fine. So that's kind of the direction I'm going to go, is how can these be economic drivers, and how can we utilize these every day, all on top of the backdrop of knowing the science of the water quality itself. It was actually my involvement with Bob's department on campus, particularly the water sampling program that he does through Purdue Fort Wayne and IPFW at the time. We had an event that one of the organizations has in town. Is called the Raft Race, and that is one in particular where people, for the most part, they're full body immersed in it. Not supposed to be, not to go swimming, but these are rafts, and part of the thing is fun. So a full week prior to that event, I would collect water samples, and this event was the St. Mary's River. So I would collect water samples, and I would take them into Bob's lab every day for analysis, so that we would know the condition of the water on the St. Mary's for this raft event, in case there was anybody from that end. And I will tell you that even though the St. Mary's is much more challenged, every time that we had that race, that week of supporting numbers has always proven that it is below the exceeding standards, and with basic precautions, we've had no problems. But this is an example of an image of the St. Mary's River, and the bench was put there. And at one point in time, you probably could see the rivers. What you see a lot there is there's a tree of heaven, a lot of honeysuckle growing in the grapevine, and you really can't see the rivers. So while I was taking these samples in preparation for the raft race event, it was midweek, and I'm talking to one of Bob's lab assistants, and she was 20-something at the time, and you're going to see her phrase in a couple of slides here. Because I was the river advocate, the river rat, wanting people to be champions of the river, to be stewards of the river. And this is what this individual said. She said, Dan, if people could see the rivers, then they might think about using the rivers. And so seeing the rivers can take a lot of different fronts. It could be removing the blocks to the rivers, so we start putting them in people's minds. It could be forums like we're having today, seeing the rivers through a scientific light to try to get an idea of what is the condition of the rivers? What do we really know about it? This is an event that was connected with Three Roots Festival, supported by Steel Dynamics, where we put people on pontoon rides. You see 3 pontoons right there. What we did over the course of 3 days, we ran Friday night, all day Saturday, and Sunday, most of the day. In one weekend, running 10 pontoons, one year we put over 4,000 people on the river in that very short time span. And so that was an opportunity to get people out. So as was mentioned earlier, are the rivers dirty? Do they smell? Are they full of trash and debris? Are they mucky? This gave people an opportunity to form their own opinion. To hopefully counteract some of the images that we started off with. So again, this person said if they could see the rivers, they think about using the rivers. And then if people will use the rivers, however you want to do it, whether you want to have someone take you on a ride, whether you are a sportsman and you want to be out there, the gentleman on the right, that was caught on the St. Joseph River between Johnny Appleseed Park and the confluence. And he's a kayak fisherman. And just so you know, that was a catch and release. He ended up with that catfish back in the river. But if you're a fisher person, I don't know if that's the right way to say that, we've worked with professional fishermen like Joe in this picture here, and we've taken the DNR samples when they take their shot boat out and count the species of fish. There are, within the rivers of downtown Fort Wayne, over 20 species of fish. Now, most people think it's just carp and catfish, carp and catfish. But these professional fishermen say, you're gonna get what you're fishing for. How are you fishing? What are you using? And again, there's over 20 different species of fish in the rivers, of which about 60% of them are game fish. You're going to see maybe another image or two. Maybe you want to use the rivers, as the upper left image showed. Maybe you just want to recreate on these. Now, the challenge, if you're out there, and there's no intention to sharing mixed messages, but the city of Fort Wayne is not unlike 700 other communities across the country, that we are under EPA mandates, 1972 Clean Water Act. We want our rivers to be fishable, swimmable by a date. We've certainly exceeded that date, but the goal was noble, and that's the goal that we keep working on. This is the confluence where the kayakers are. They just happen to be a group of volunteers that work at the local zoo, and this was kind of a reward for them to go out and kayak on the river. So here's a great picture of people enjoying the rivers, but there was a concern on our water treatment organization within the city, because at this time we were still negotiating with the EPA consent decree, and as the science will tell us, that if we have a major rain event, that we will exceed our levels in a variety of parameters that Bob shared. But the most harmful to human involvement like this would be the E. coli, would be the fecal bacteria. And the concern of this image was, hey, maybe the storm just went over, and this is within 12 or 24 hours, and the fecal bacteria load could still be elevated in the rivers, and we don't want people recreating on them. And so I can certainly understand the cautiousness of using and promoting images like this. And only from someone probably like me that knows the rivers, I can tell the level of the bridge to know we haven't had a rain event. But as you see data and then see images of people using the rivers, you may get mixed messages, and for that reason, what did happen just a day or 2 or 3 prior to this has a big effect from the hydrology standpoint. If we get a rain event, and the conditions of the water could be totally different. So to bring up the fourth point of the phrase, is that lab tech said, Dan, if they could see them, they think about using them, and then when they use the rivers, then they will probably care about the rivers. And so that put me on the path of not taking somebody and shaking them by the shoulders and saying, why don't you care about the rivers? To a pivot to say, I want to get people to see the rivers, and then let them decide for themselves how they want to use the rivers, and let them decide for themselves how they want to care for the rivers. This image right here, that is all honeysuckle. And this is a volunteer group that was in cutting down honeysuckle. We don't need to get into the weeds right now about why honeysuckle is bad for the riparian environment. It is, and we eradicate it. So we are working on solutions. My approach has a tendency to be less technical in concept. On the right-hand side, we have put a lot of pipe in the ground. That was in reference to the subsurface drainage. Now, we don't have 600,000 miles of pipe that size. But maybe what we need to do, in addition to treatment plant upgrades, is to think about how can we make the landscape more like a sponge? How can we work towards keeping the water where it falls? And that is a lot of the initiatives that are out there. City of Defiance right now has some demonstration projects with pretty hefty price tags of rebuilding wetlands to be the natural kidneys of the rivers, to allow that heavy rain event that came, rather than keeping it channelized in the river, let's let it spread out. When it comes up a foot or two, slow down, drop out some of the sediments, do some of the phosphorus reduction in the plants that it's traveling through. So how do we make it more of a sponge? I mean, that's just a simple concept that I think will get us to where we want to be. Simple concept, not so easy to carry out. This is just a map showing what I want to emphasize is the Maumee River between Fort Wayne and Defiance. The Maumee River is right in the middle of the screen, and you can see that it has that typical river sort of profile where it's squiggly and it wiggles back and forth to create oxbows. And again, I'm not the scientist, but what I want to emphasize here is that is a very old stretch of the Maumee River. If you would look at this map from Defiance and up through Napoleon and on out, it is a lot straighter section. That's a lot younger feature. Again, as the glaciers recede, we're talking about thousands of years of moving back and forth. But what is also telling to me of this image is the straight lines. And as we get into Ohio, and even in Indiana on the Maumee River, one of our challenges, obviously this was the Great Black Swamp, most of us know that. And in order to put it under production, there was tiling. This is where that 600,000 miles of subsurface drainage is. There were ditches dug to be able to drain them. And that, in fact, then leads to this, as I use the word, we kind of power wash the countryside when it rains. It hits the ground as quickly as possible. We push that volume into the receding streams, thereby creating some problems for us. And I want to highlight what Bob had said on the water monitoring program is rarely is a sample taken right from either the St. Joseph, St. Mary's, or Maumee River. More likely, it's up on a tributary to see what is the health of the water coming in. And if there is a challenge somewhere in this process, then we've got a better idea of looking back up into the area and saying, okay, what is the specific best management practices that we could put into play at this location? And there's been lots of benefits from all of that data from the water quality monitoring program, but I want to just share one unintended consequence, but probably exactly what we are hoping to achieve by understanding the quality of the water within the receding streams. At a general presentation of the water quality monitoring program with a lot of producers, and I'm going to say this was maybe 10 years ago, 7 years ago, something like that, a snippet of the WQIS data was pulled out. And the reason it was pulled out was to show, number one, the power of the data of collecting it and what we can do with it. And number two, to show the fact that there was an anomaly that just didn't make any sense. And so Bob and Greg, if I mess this up, clear it up a little bit again. I talk in broad strokes. But there was a spike, I believe, in the pesticide atrazine. And I think it showed up in July or August. And for those that are in the farming world, that's not a chemical that you're going to be putting out on the fields that time of year. Well, it came to pass that there was a gentleman in the area, and I think he ran an ag retailer store, and in that time period, July, August, atrazine, which was applied very early in the springtime, there were some equipment that needed to be cleaned out, and this was not a wanton disregard of a chemical and an irresponsible process. But it had a summer employee there. Hey, go wash out the tanks. It was probably out on a gravel parking lot or what have you. But that washout water found its way into a receiving stream, found its way into a sampling bottle. Fortunately, we were there, and it was an aha moment for that ag retailer to say, well, I need to be a better steward of what I'm doing with my equipment as I'm cleaning it out and preparing for the next use. So again, this isn't so much calling out that unfortunate accident, but calling out the value of the water quality monitoring system and where we can see anomalies and how we're able to go back up into the tributary bed and say, okay, what are the corrective answers that we should be looking at suggesting in this area? Because it varies between watershed and what stretch of the river that you're on. So as we look at these and we want to bring people back to the rivers, what's causing these problems, this is just kind of a worn out slide, but it's very indicative of some of our problems. So maybe I'm wandering into the science area a little bit, but I did want to share this for two reasons. Number one, Indiana is not alone. I think most of the states throughout the rest of the country experience the same thing. 50, 70, 85% of wetlands have been lost. They've been filled in, they've been put into production, they've been put into cities, they've been put into golf courses. I don't know what they put in there. So those wetlands, we're losing them. And it's sort of ironic that one of the solutions to our high phosphorus loading the rivers, they lie into rebuilding wetlands and using those as sinks to flow that water in there and pull out some of that excess loading that's in there. We've done a lot of things in urban areas that are problematic. I don't mean to grind too much on Fort Wayne, but this is a land use map showing zoning. And if anybody's familiar with Fort Wayne and Promenade Park, that's kind of shaded in there in yellow. But what I want to point out is that red circle where the 16 is. And I've enlarged that, and you see where it says former riverbank. And if you would zoom out and look at the St. Mary's River, you're going to see that there's a very sharp 90-degree bend that's put in the river. And you see the railroad in a gray strip that has IN2, that's the zoning of it. And as it has been explained, the river had a much more gradual turn, probably went right through that number 16 and carried on. But in order to bring railroads in, last century, they can't make sharp turns, so they just filled in the river and pushed it. The green area, that is Bloomingdale Park. A lot of work has been done to restore that. What we found as we begin to remove honeysuckle and work there, that was basically a city dump. So some of the challenges we have with water quality certainly are a result and driven by urbanization along these areas. So we also have to be mindful that at least through urban cores, even though we want to be on the river and think we're in a very natural environment, there probably isn't anything that's real, true, natural about the rivers because what we've done alongside them. So we've got these issues ahead of us in metropolitan areas as well. But I come back to the comment, if people could see the rivers, they think about them. If they think about them, they use them. And this was just an editorial piece a few years ago that says using the rivers is a good start. So this is just talking about getting out there, getting aware, learning firsthand what is the condition of our rivers, and thereby that's going to provide the community support, which turns into votes and the public support as there's initiatives, both rural and urban, to address our water quality issues, not only safeguard them, but to try to improve them. So again, however you use the rivers, get out there and do that. Again, you know, on the left, we do have a lot of wildlife along the rivers, but our human use could hamper that. We put a lot of loud party boats out there. We've got an airboat that runs. Anybody in a kayak that wants to see nature, they're not going to see it for several hours because they've been scared away. I think, I'm not a fisherman, but I think this is some selected species of fish that people want to catch now. This is a catch and release sort of fisherman. And I think that's a northern, I'm not sure. Bob, I will jog your memory to come back to the sockeye study. This, I think, is where the power lands as we go forward to improving our water quality. This just happens to be the Indiana Tech wrestling team. As I would amass groups to remove honeysuckle and restore native vegetation along the rivers, we would not only do the fun physical work, but we took an opportunity to educate those that were joining us about the value of being good stewards of the watershed, being mindful of the water quality, and hopefully these folks will then carry it on. Again, we shared that with, this is the same image, okay? This is what the river drained over the winter period. And this is just some summer night as the sun's going down, same area. So we've got a lot of value to using our rivers. We've got people on them. We need to use the science that Bob and others are creating to help those that are using the rivers and along the rivers to be the best stewards they can, because this is going to happen and this is going to continue to grow. And we want to make sure that our communities are a great place to live, that we've got a good quality of life. And here in the Midwest, lacking mountains and oceans, it is our rivers, streams, and creeks that provide some recreational opportunities. And so this is a win-win for everybody as we take a serious look at our water quality. City of Fort Wayne has adopted a riparian management plan. This is just kind of the idea, the table of contents of what we're dealing with in the riparian buffer. So there's eyes here to make this more manageable. Again, that was sort of driving this. This is a restoration project at the bank. This is under construction. It is now done. It's a very win-win story, and there's going to be no more erosion off of that bank. But just upstream of it in this area, we've got more areas to work. So hopefully the public's beginning to see we're trying to be good stewards and minimize that erosion potential. Purchasing equipment, that's what's helping with a lot of this. You've seen that image. This is one piece of science that I want to share that is very problematic. Bob's data, I thought this might have been from 15. We had a very similar event in 2015, but this is from spring of 2013. This is a rain event. And this is a gauge in downtown Fort Wayne. And all I want to emphasize is that this river basically rose 8 feet in 12 hours. The timeline down there with the dip almost goes off the green line. That's 12 o'clock in the afternoon, April 19th, that's midnight. And then by 12 o'clock the next day, it's already up to 19 feet on the flood gauge when it started off at 11 feet. So that's about an 8-foot rise in 12 hours. Now, we saw this coming. This was an example of a very concentrated rain event in the St. Mary's River. Very flashy. We've got water coming in the river off the streets, off parking lots, off additions, off rooftops. And we've also got a lot of drainage out there, so it's bringing that water in as well. So this is the sort of environmental hydrology impact that we see on the rivers that's not very friendly to the banks. So we use the rivers, we recreate on them. The image on the left is actually a regatta that we had in town, so we are starting to put people in the rivers. They are very usable. Here's the image of what most people see when they see the rivers. They see a very chocolate brown cover. This happens to be during a high rain event. So mostly what you're seeing there is the St. Mary's River. Again, we started with that one. This is the St. Joseph River. It's in November, late November, around Thanksgiving. You can see the bubbles at the bottom. I am looking through at this time just about 3 feet of water. So given enough time, that clay will settle out. And again, I went out and saw the river and saw how clear it was, and thought I had to take this picture because most people will never believe that you could see more than a half inch into it. So again, I forget what the measurement was on this, but I think it's something like 26 inches of water looking right down to the river bottom. So if we give the river half a chance, if we can keep this massive inflow of water into the rivers, that's not only going to help with clarity and suspended solids, but that's going to help with the other matters, as Bob talked about, that attach themselves to that suspended solid loading in the rivers. When the rivers are down, this is St. Joseph area. This is not very far from where this picture was taken. It was at this low water condition. So the bottoms of our rivers, for the most part, they're rocky when you get through the sediment, so they can have a tendency to clean themselves. Again, we're recreating on this. It is a huge economic boom for communities. Not only does Fort Wayne recognize that, Defiance is starting to utilize that. Decatur has ideas to more monetize the riverfront, as does Auburn. And it's not a new idea either. So in 1921, 100 years ago plus, as the city of Fort Wayne, we talked about better engaging and utilizing our rivers. So we need to keep up that good fight. We need to make sure we can do what we can do to be good stewards of the river, removing the invasive species, working with the younger children. These are a group that we went out to do some honeysuckle removal, and we just had to take a lunch break. You'll see that picture of the kayakers in the back. I try to use that as motivation. Again, we've got an opportunity here that we're investing in the rivers not only locally, but we're doing it across the area for the improvement in the water quality monitoring. There are ways of getting out and enjoying the river. Let's never forget that we can do that. Not get too wrapped up in science and scared away from using the rivers. And however you see them, they are your environment, and we want to be good stewards of our rivers. So I think I'll sort of end there, see if anybody may have any questions. My final comment is, once again, water quality can be a matter of perspective. And again, this is not Photoshop. It's not to be a trick image. I like to show this and say, well, the rivers look blue to me. Although if you get a different perspective, obviously this water is very brown because it's got sediment in it. And I think we're all working in the right direction on this one. Anybody have questions or comments that they'd like to share?
Anybody have any questions? What questions do you have? Let's see if you can get these guys.
Well, okay, Bob, I'm going to go ahead and stop sharing here if we got a question come up, because I think what you've got there is rivers. What's actually living in the rivers is very helpful to know.
Well, I think we should give a little bit of time here. Let's see what happens, and I'll go there if we have to.
Okay.
Okay. Jim Mosley here. I'm a farmer and have a background in agriculture and agricultural policy. Worked at EPA in DC for a while, was U.S. Department of Agriculture lead head, deputy secretary for a while, had Natural Resources and Environment Undersecretary at USDA back many years ago, but primarily I'm a farmer. And as I listened here, I was fascinated that you talk about the phosphorus, the nitrogen, fecal material and so forth. And of course, I'm quite aware that agriculture contributes to that along the way. And the solutions you gave are legitimate things I think that we look at. but you didn't take it all the way back to, at least for the farming community, the real source. And that is what happens on the land and how that activity on the land can contribute. So I'm just curious how that goes into your thinking, and is it believed that that's such a huge political difficulty to get that change at that level that it's not worth really spending a lot of time on? Or I'm just curious about, from your perspective, particularly Dan, how do you see the agricultural community, and what's your considerations for trying to approach them?
Jim, I'll give you my input and what I've learned over a little bit more than a decade, and I'm hoping some others might join in as well. You are right that as we look at the science and what's the loading, what's coming into the rivers, gradually that spotlight is getting more and more focused. And I think it's just an easy draw that the majority of the land use, depending on the county and state, between Fort Wayne and Toledo, is agriculture. We could look at probably the smallest percentage of land use being ag would be in Allen County. I think that's about 60-65%. But some of the counties on the way to Toledo are as much as 85% on crop production or livestock. And certainly the studies have shown that agriculture is a major contributor. And I think there's a variety of reasons for that. And I like your pointed question, is that too big to battle? And I don't think that's the case. I know there's a lot of initiatives out there. But again, I'm just a common guy, but pontoon rides, I ended up taking supervisors for the Soil Water Conservation District, I'm going to say probably 12 years ago now, for a pontoon ride. And all I took were city folks. These guys started talking about ways of being good stewards of the bank, being good stewards of the water, what they could do. I had no idea what an SWCD was, what a USDA was, what's an NRCS. I had no idea. I was invited to become a supervisor, and I was very pleased with my experience there for about 5 years as a supervisor. Not really sure how long. I am still an associate supervisor with SWCD in Allen County, Indiana. So I recognize the big challenge out there. The one story I want to give, and I think this is what we're seeing, is there's a lot of initiatives in the ag world. Can there be more done? Yes, there could probably be more done in the urban environment. But, and again, I'm going to paint with really broad strokes, but I think this is sort of representative of what we find. We take 2 steps forward, and then we find we've taken 1 step backward. The science is a little bit old, but it just resurfaced again in a recent presentation by someone on the rivers and water quality, and particularly ag's contribution to phosphorus loading. Is we had coal burning power plants, and we were getting a lot of sulfur, and so we had acid rain. So the fix to that was to put scrubbers on the stacks that remove the sulfur from it. And what it began to show us is that sulfur would bind up phosphorus in the soil. So acid rain, not a good thing. The advantage to it was it tied up the extra phosphorus that wasn't being taken up by the plants. And by reducing acid rain, we sort of excalibrated the problem of the excess nutrients in the soil, and the phosphorus began to loosen itself up and find its way into the waterways. So yes, correcting acid rain, 2 steps forward, great call. 1 step backwards is we lost that free, if you can say that, soil amendment that helped tie up phosphorus. Now take that same concept, and now we're beginning to find that tile drainage management, where we're going to put some stops in the tile drains where they reach a receiving stream, try to maintain some of that moisture for the crop benefit. We're finding that maybe keeping that soil moister is creating problems where we have rain events that is, again, working with that legacy phosphorus that's in the soil, making it easier to move and find its way back into the receiving streams. So, Jim, that's my quick answer to ag being a contributor. And again, in municipalities, we refer to that as point source. We go put a cup underneath the pipe and we know exactly where it's coming from, who's responsible for it. When we get the non-point source that spreads out, across the countryside, a little bit different, more difficult to identify specifically the sources so we don't target it. Yes, I shared the story about the gentleman washing out some tanks and showing the atrazine spike. It was great. That was a teachable moment for everybody. But we need to take this data and do what we can to get closer to the sources, but also understanding that science is going to continue to keep changing. And I don't see that Greg's on here anymore. And Mike, you might be able to share this with what Mark Williams is finding with some climate patterns recently in Northeast Indiana. And then I'm not sure the scientist at Purdue that is looking at where some of this additional phosphorus is getting into the streams from. Mike, would you be comfortable in touching on either of those? Might help you.
Well, number one, I am a farmer. That's my real job. The Soil and Water Conservation District here is working with the farmers to promote practices. I have implemented the majority of available practices. I think I am helping cut down on my phosphorus and nutrient removal and also sediment. So we're working towards that. Your question about where is it coming from? The SWCD is involved with the USGS and Purdue University, possibly a couple others coming up on helping quantify what conservation practices can do. The source of some of the phosphorus now is interesting to be possibly coming from stream banks, not all of it directly from farm ground. So there's, I guess, more to come on that. It's a big story. But I do like to say that we are working towards it, but we have a long ways to go in agriculture.
This is Jim Mosick, and I would agree. The one thing I keep looking for here is, and Mike, I know you're well aware of all the practices, you probably are involved in them, but one of the major changes that's happened with agriculture working the land for food production is the fact that historically we had some kind of living vegetation, living roots on the land year round. And I do think that we're underestimating the ability of, if we can do a good job of cover crop implementation in agriculture and farming practices, that goes a significant way. I've driven that area between Fort Wayne and Toledo. This is an issue that fell on my radar screens, particularly when we had the problem there in Lake Erie. And if you look at that as a farmer, if you look at that watershed, there's an enormous amount of that land that just simply has no cover on it. And in fact, it doesn't even have much residue from the previous crop on it. A lot of it is heavily tilled. And I think what we can validate is that as we've seen additional tile laid over the last decade and a half, because that's become a really important, we understand that aerated soils are important to production. And so if we can get the right mix of oxygen in the soil, because we're taking the water out, removing the saturation point, then we get improved productivity. The fact is that we have a kind of a double whammy here. We have tile, which is a kind of a main line to the streams. And at the same time, we don't have any living roots now, or living plants, living roots that can actually capture and hold those nutrients. So as you think forward in terms of Fort Wayne and what all you're doing in that watershed, the whole question about where we go with cover crops and agriculture and trying to keep a living system going. And yes, restoration of some of the wetlands if it's possible. And I mean true restoration of the wetland, because some of them are still kind of wetlands, but they just don't function fully as in that capacity. Those are some things that, from my perspective, on my side of the fence of agriculture, that we're going to have to begin to do. And it's certainly not just from Fort Wayne to Toledo.
Well, I would agree 100% with that, Jim. That really has to be worked on. Is there any other comments, questions?
Mike, I just saw a chat come up there, a question about what can the average person do? And I think that's a very good question, and I'll go ahead and take that just as a minute. We've got someone on board with us, Jane Young, who has been associated tightly and loosely at times with one of our local grassroots organizations called Save Maumee. And so what can the individual person do? Look for an organization, a watershed organization. There's lots of them out there. I happen to be the vice president of the Maumee Watershed Alliance. With that alliance, it's a kind of a loose partnership where we want to assist. Underneath that umbrella of the Maumee Watershed Alliance is Save Maumee, Friends of the Cedar Creek, Upper Maumee Watershed Project, Sage Hill River Watershed Initiative. So it's ideally all of us are pulling in the same direction. So what can an individual person do? Number one, maybe find an organization that is out there doing the sort of things that you like. So I'm going to draw some comparisons here. Save Maumee is very good at communicating with the young folks in the community. Doesn't mean if you're over 30, you can't participate. You absolutely can. I have. But they actually provide a lot of tactile opportunities. They provide opportunities for people to get out and remove invasives. They provide opportunities to get out, people to get out and replant the native trees and the native vegetation. They do a lot of education about many of the things that we've talked about here. Individually, then, we've got a couple of events coming up that rather than me going through the list of everything you can do, you might want to participate. In September 15 and 16, the Maumee Watershed Alliance is going to put on what's called River Summit 3. That will be held in downtown Fort Wayne. One day will be at Promenade Park. The other day will be at the Grand Wayne Center. And then we're going to connect with another organization called Friends of the Rivers in Fort Wayne. And they are celebrating World River Days on September 26th of this year. And that's at Promenade Park. And again, there will be a lot of activities and watershed organizations there sharing very much hands-on things that the individual person can do. So be mindful of your storm drains. Make sure that only rain goes down there. Be mindful of what you're planting in your yards. If you're fertilizing, make sure you don't put that out on hard surfaces. There's just lots and lots of information that can be done. If somebody's really looking for specific ideas, you can go to the City of Fort Wayne City Utilities website. I'm certain Defiance City Utilities would have the same thing. A lot of the watershed organizations will have a whole list of things that an individual could do to be better stewards of the water that finds its way into our rivers. Mike, there were some other questions I didn't track as they were coming in.
Yeah, well, the SWCD here has a number of projects going on that we can do with the water sampling, soil sampling. We can help with other things like that. So that's always interesting. We do have a few test kits available from the Indiana Department of Agriculture. They're simple tests, not like the ones that Bob is talking about, litmus tests, business paper tests. So if anybody's interested in one of them, just to kind of get an idea of testing, we have that available here in the office.
Just wanted to bring to everybody's attention that Jane did put Save Maumee's website and Facebook on there. If you want to look, I'm certain they have a lot of things that an individual can do. But I think all of us, rural and urban, scientists and non-scientists alike, as long as we arm ourselves with the right data and with a smile on our face and energy, go out and tackle what we can, we'll eventually get there. And Jim, I really appreciate your background. I think you and I may have traded a couple of emails back and forth. So I see Mike plans on getting a hold of you. Yeah. I would like to join in on that conversation Jim. I think you've got a lot of historical perspective that I could certainly learn from. Would love to do that.
Mhm. Bob, do you have anything else to add today?
No, I want to thank everybody for listening, and I would just like to echo Dan's recommendation. If you have a passion for helping out, start with the organization, contact the SWCD, the utilities, find a way to get involved. It's very rewarding. I've been doing it for, well, I don't know. Mid 90s. I don't know. Yeah, it's a long time, and I'm still doing it even after I retired from my real job. So yeah, get involved.
Bob, we look forward to having you around a long time yet, so you have to stick here.
All right, I'm not going anywhere, Mike. We're all right.
Well, I certainly want to thank Dan and Bob for sharing their knowledge and definitely their passion with us today. This has been really great. It's one of the best ones we've had. I want to get a plug in for our next coffee. It's going to be Coffee and Compost with Brett Bloom from Dirt Wayne and Megan Masterson from Ground Down Compost. I hope I got that right. It's June 15th, 2021 at 8:30 to 10:30. You'll get the same information from our website and all the blasts that you've been getting that. We have the self water testing kits available if anybody would like to get their fingers wet on that. It's an interesting thing. It's not quite as scientific as them, but it does show you what the process is. If no more questions, I think we'll probably say good time. Any following questions, comments?
Yeah, Mike, I need just a minute so I can get your phone number here. Don't drop me off yet. I'm trying to get so I can give you a call.
I put the number I put up there is the office number here for the Allen County Soil and Water Conservation District. So you can find that on our website, or anyone else. We're always available to talk. And I think any discussion we have is always good.
Yep.
Right.
I have a question, or maybe an observation. I feel like sometimes there's a disconnect between urban development and water quality. And I'm wondering what information the city, like a Fort Wayne, is taking in, because I see a lot of impervious surfaces that are being put down, and medians that are raised that aren't being used to capture water. A lot of things that seem like they could be doing to help capture water so that we're getting less runoff and maybe improving some of these issues.
Marissa, let me just share a couple things very quickly here. I really like your comment. Promenade Park in downtown Fort Wayne. When I take people by there on a tour, they look at it and say, oh, geez, look at the concrete, look at the building, look at the trails. That particular site was totally commercial. It was all hard surface. There were 5 trees only on the site of Promenade Park. Those 5 trees are still there. And what has been added to it on both sides of the river is about 150 more trees. The bioswale that goes right down through the middle of the park with a lot of beautiful plantings, it's a very functional piece of infrastructure. Rarely does any water that falls on Promenade Park or the adjoining Superior or Harrison Street does it make it into the river. That's designed to capture all of the storm water from that area, percolate it back down through the ground, water the vegetation that they have growing there. So the first answer to your question is we've got hands-on sites there that we have purposely built in so we can use those as teachable moments. And I know that City of Fort Wayne, City Utilities on their website, they've got a lot of things that they're doing to help people understand rain gardens, rain barrels, those sort of initiatives. And I do know that as Riverfront Fort Wayne proceeds, there's a very pointed approach to being mindful of not only our flood regulations, but also the environment to make sure that we are accommodating. So Marissa, I hope that helps a little bit, but I know that City Utilities website's got some very friendly pieces in there on if you're going to development, if you're going to do some development, building and development, these are the elements that will be, looked favorably upon for not only the environment, but just make it a comfortable place to be and safeguard our water supply as it is. The rainwater is going to drain into our rivers. I hope that helps a little bit.
Thank you.
Yeah. Great job, everybody. Thank
Hey,
you.
thank you, Mike.
I think
Thanks, everyone.
We'll call it a day. Thanks. Thanks for joining.